What if the speed of light was slower? Imagine a universe where light doesn't zip around at its usual breakneck speed of 299,792 kilometers per second. Instead, it meanders, taking its time to travel from one point to another. How would this change our understanding of the cosmos? Imagine light crawling across the universe instead of zipping around. The stars we see twinkling in the night sky would appear much different. Their light would take longer to reach us, altering our perception of the universe's age and size. The night sky would be a different tapestry, with stars appearing in places they wouldn't be in our current understanding. This isn't just a thought experiment, it has profound implications for how our universe works. Scientists and astrophysicists would have to rethink the fundamental laws of physics. The speed of light is a cornerstone in equations that describe everything from the behavior of particles to the expansion of the universe. A slower speed of light would mean re-evaluating these principles and potentially discovering new ones. We often take the speed of light for granted. It's a constant that underpins much of our scientific understanding. From the way we measure distances in space to the way we understand time itself, the speed of light is a fundamental part of our reality. But what if this constant was different? How would it affect our daily lives and our technological advancements? It's the fastest thing we know, a fundamental constant in physics. The speed of light is not just a number, it's a limit that defines the maximum speed at which information and matter can travel. This limit is crucial for the laws of causality, ensuring that cause precedes effect. If light were slower, our entire understanding of cause and effect could be turned on its head. But what if this constant wasn't so constant after all? What if the speed of light could change under certain conditions or over time? This idea opens up a realm of possibilities and questions. Could we harness this variability for new technologies? Would it mean that the universe is more dynamic and less predictable than we currently believe? The implications are vast and could lead to a new era of scientific discovery. Light travels at an incredible speed, approximately 299,792,458 meters per second. To put that into perspective, if you could travel at the speed of light, you could circle the Earth more than 7 times in just 1 second. This mind-boggling speed is not just a number, it has profound implications for our understanding of the universe. This speed is the foundation for many laws of physics, including how we understand time and space. The speed of light is a constant in the universe, meaning it does not change regardless of the observer's motion or the source of the light. This constancy is crucial for the equations that govern the laws of physics, such as Maxwell's equations for electromagnetism and Einstein's theory of relativity. Einstein's theory of relativity tells us that time and space are intertwined. According to this theory, the speed of light is the maximum speed at which all energy, matter, and information in the universe can travel. This theory revolutionized our understanding of the cosmos, showing that time can slow down or speed up depending on how fast an object is moving relative to the speed of light. This phenomenon is known as time dilation. The speed of light acts as a kind of cosmic speed limit, influencing how we experience both. For instance, because light from distant stars takes time to reach us, we are actually looking back in time when we gaze at the night sky. The light from the nearest star, Proxima Centauri, takes about 4.24 years to reach Earth. This means we see the star as it was over 4 years ago. The speed of light also affects technologies we use every day, such as GPS systems, which rely on the precise measurement of the time it takes for light signals to travel from satellites to our devices. Understanding the speed of light helps us navigate not just our planet but the vast expanse of the universe. If light were slower, one of the strangest consequences would be time dilation. Imagine you could travel at a significant fraction of the speed of light. At such high speeds, time would actually slow down for you relative to someone standing still. This isn't science fiction. It's a real phenomenon predicted by Einstein's theories. A slower speed of light would also affect the fabric of space itself. Gravity, as we know it, is caused by massive objects warping space-time. With a slower speed of light, this warping would be more pronounced. Imagine a bowling ball on a trampoline. A heavier ball or slower light speed would create a deeper curve. These changes to time and space might seem abstract, but they would have tangible effects on our everyday lives. For example, GPS technology relies on the precise timing of signals from satellites. If light traveled slower, these signals would take longer to reach us, making GPS navigation much less accurate. Imagine your sat-nav constantly directing you to the wrong location. Even the colors we see would be affected. The color of an object is determined by the wavelengths of light it reflects. A slower speed of light would alter these wavelengths, potentially shifting the colors we perceive. Imagine a world where the sky isn't blue, but a different hue altogether. Our technological world would also experience a dramatic slowdown. Computers and smartphones rely on electrical signals, which are ultimately governed by the speed of light. With slower light, these devices would process information at a snail's pace. Imagine waiting hours for a simple web page to load. Ultimately, a slower speed of light would result in a vastly different universe than the one we know. Stars would burn differently, galaxies might form differently, and the very laws of physics would be rewritten. It's a humbling thought that something as fundamental as the speed of light can have such profound consequences. While the idea of a slower speed of light is hypothetical, it opens up fascinating discussions about the nature of our universe. Imagine a universe where the speed of light is not the constant 299,792 kilometers per second that we know today, but something significantly slower. This change would alter the very fabric of reality as we understand it. It highlights the interconnectedness of our universe, showing us how deeply intertwined the laws of physics are. The speed of light is not just a number, it is a fundamental constant that affects everything from the passage of time to the structure of space itself. Time, space, gravity, and even the colors we see are all influenced by this cosmic speed limit. If the speed of light were slower, time would stretch, distances would expand, and the universe would look vastly different. The colors we perceive in the night sky, the way light bends around massive objects, and the very nature of gravitational forces would all be altered. This cosmic speed limit is like a universal metronome, keeping the rhythm of the cosmos in check. Are all influenced by this cosmic speed limit. It's a reminder that the universe is a delicate dance of forces, each one playing its part in the grand symphony of existence. It's a reminder that the universe is a delicate dance of forces, and even a slight change to one constant can have ripple effects across the cosmos. The speed of light is not just a barrier, it's a fundamental aspect of the universe that shapes everything we know. And even a slight change to one constant can have ripple effects across the cosmos. Scientists and physicists spend their lives studying these constants, trying to understand the underlying principles that govern our reality, can have ripple effects across the cosmos. The more we learn, the more we realize how much there is still to discover. The universe is a vast, intricate web of forces and interactions, each one contributing to the grand tapestry of existence.